Okay, we're going to talk about parallel and perpendicular lines. Now, we've actually already talked about some of the basics to parallel and perpendicular lines, but we're going to kind of go a little bit deeper in it today. So we realized in the last time that parallel lines, first of all, have the same slope. Okay, so their slopes are exactly the same, but they have different y-intercepts, right? Okay, because if they had the same y-intercept, they'd be the same line. Because it's got the same slope, it'd be starting at the same spot. It would be the same exact line. So, parallel lines have the same exact slope, but they have different y-intercepts. Alright, so that's the first thing you need to know. Alright, so now we have an example down here, and it asks you, determine whether the lines of y equals negative 3x plus 4 and 6x plus 2y equals negative 10 if they are parallel. Now, there's two, again, criteria that we need to figure out. If the slopes are the same and if they have different y-intercepts. Okay, so, well, on the first one we can tell really fast, right? Here is our slope and here is our y-intercept. Well, in the second one, though, we can't tell that really fast, so we can't tell if they're parallel or not. So what we have to do is we actually have to solve this first for, put it in slope-intercept form, and then once you do that, then you can check to see if they're the same. So we're going to solve for y. So we're going to subtract 6x from both sides. Oops, that should be 6x, not 6y. Sorry about that. So we have 2y equals negative 6x minus 10. And then we divide by 2, so divide everything by 2. And you get y equals negative 3x minus 5. So let's look. Our slope in this one is negative 3, and the slope in the other one was negative 3, and our y-intercept is negative 5 instead of positive 4. So yes, they are parallel. So yes, they are parallel lines. Okay, because their slopes are the same and their y-intercepts are different. Alright, so I mean it's as simple as that. Get them both into slope-intercept form and check their slopes. Are they the same or are they different? If they're the same, then check their y-intercepts. The y-intercepts are different, they're parallel lines. If the y-intercepts are the same, they're the same line. So no, they're not parallel, they're the same. Okay, there's a couple try these. They start right at the bottom of page 1 and they move over to page 2. So give those two a shot really fast and then come on back. Alright, so the first try this. We want to know if these lines are parallel. So 3x minus y equals negative 5. 5y minus 15x equals 10. Alright, so the first step should have been get them in slope-intercept form. So solve for y. So minus 3x from both sides. Get negative y equals negative 3x minus 5. And then we're going to multiply or divide by a negative to get the y positive. So we got y equals 3x plus 5 for the first one. Okay, second one, we need to add 15x to both sides. So that's gone from there. We got 5y equals 15x plus 10. Divide by 5 to everything. We got y equals 3x plus 2. Okay, so let's look. Slopes, both are 3. We're good there. Y-intercepts, 5 and 2, two different ones. We are good. So yes, they are parallel. Alright, let's check out the next try. Alright, so again, y is not solved for in the first one, but it is in the second one, so that's good. So we're going to divide by 4. All the way across, we got y equals negative 3x plus 4. And then the second one, y equals 3x plus 4. Let's look. So our slopes, negative 3x, positive 3x. Those are not the same, so no, they are not parallel. It's just as simple as that. Alright, so on the next part, they start talking about perpendicular lines. Now, I'm going to go to a new screen here. perpendicular lines we talked about before. Okay, perpendicular lines make right angles. Okay, so they're exactly right angles, and we talked about before how perpendicular lines, their slopes. Okay, let me write perpendicular here at the top. Perpendicular, okay, their slope, and hopefully you remember this because it was on your test, is negative reciprocals. Hopefully I spelled that right. I'm probably not going to. I think I spelled it wrong. Oops, sorry. Well, you get it. It's a negative reciprocal. Oh, that's what it is. It's the O is on top. Reciprocal. Anyway, so they're negative reciprocals. So if the slope of one line is 3, then the slope of a perpendicular line, okay, so if the slope of one line is 3, the perpendicular slope equals negative 1 over 3. So you make it the opposite sign and you flip it. Okay? Alright, so the example here that they have, they say, tell whether the graphs of 3x, let me flip over to a new page so I have some more room. Tell whether the graphs of 3y equals 9x plus 3 and 6y plus 2x equals 6 are perpendicular. Now, perpendicular, okay, they have to have negative reciprocals for their slope, but their y-intercepts, it doesn't matter where they're at because they're not going to be the same line because the slopes are different. Okay, so the y-intercept doesn't matter. It's just about the slopes. Okay, so we've got to solve here again, just like we did with the parallels. Divide by 3 all the way across. We get y equals 3x plus 1. And over here, we got to subtract the 2x, and we get 6y equals negative 2x plus 6. Divide by 6. We get y equals negative 1 over 3x plus 1. Alright, so let's take a look. Our slope is 3, and our slope is negative 1 over 3. So the reciprocal's true. They're 3 and 1/3, and one's positive, one's negative. Yes, they are perpendicular lines. Alright, so that's perfect. And if you wanted to graph them, so in your notes it actually graphs it for you, so you could take a look at that graph if you wanted to. Anyway, and actually the y-intercepts were exactly the same, so that worked out pretty well too. Alright, so a couple try these, give it a pause, check it out. Alright, first try this. 2y minus x equals 2, and y equals negative 2x plus 4, and we want to know if these are perpendicular. So, first step, get them both into y-intercept form. So we got to bring that x over. We got 2y equals x plus 2, and then we divide by 2. Well, if there's nothing before the x, remember there is a 1 there, so I'm going to divide by 2. So we got y equals 1/2 x plus 2 over 2 equals 1. And then we got y equals negative 2x plus 4. So let's take a look at our slopes. So we have 1/2 and we have negative 2. So those are reciprocals, and one's positive, one's negative. So yes, those are perpendicular. Cool. Alright, let's go to the next one. Alright, so we got 4y equals 3x plus 12, and we got negative 3x plus 4y minus 2 equals 0. Alright, so let's solve the one on the left first, because that seems to be a little easier. Divide by 4. Oh, sorry about the multicolors here. That makes it a little more interesting. We get y equals 3/4 x plus 3. Alright, and here we're going to do plus 3x to both sides. When you get good at this, you can do both steps in one, but we're going to take it one step at a time for now. Equals 3x, and then we do plus 2, 4y equals 3x plus 2, divide by 4. We got y equals 3/4 x plus 1/2. Okay, well, if we look at our, sorry about that, slopes, we have 3/4 and we have 3/4. Now those are the same, Now if we were doing parallel, this would work out pretty well because the slopes are the same, but and the y-intercepts are different. So these are parallel lines, but they're not perpendicular lines. So if we were going for parallel, we'd be in good shape, but we're not. We're going for perpendicular, so that's going to be a no. Okay? Alright. The last part. Write an equation for a line containing 1, 2, and perpendicular to the line y equals 3x minus 1. Okay, so we have a point and then we have an equation. So we haven't really dealt with this before. Now the good news is we do know a couple different ways. We know we have a point slope formula and we have slope intercept form that we can use to figure out an equation, right? So we have to choose one of those. Now we don't have an intercept here, so we can't do that. But what we can do is we have a point and we could probably figure out the slope of our perpendicular line by looking at the equation on the right. Okay, so because our slope for the line that's there right now is 3, so if we want a perpendicular slope, we're going to flip it, or do the reciprocal, and make it negative. So we have a point and we have a slope, so we can do point slope form. So we got y minus y1 equals m times x minus x1. Now this is why we don't ever forget what we're learning, because we'll be in trouble if we forget all these little things, right? Because we're kind of bringing a lot of stuff in back together, so you got to make sure you know all your formulas. Alright, so we got our point we're going to use there, and we got our slope we're going to use there. Alright, so we got y minus, y equals, no, y minus, there we go. So y minus 2 equals negative 1/3 times x minus 1. Alright, so we distribute negative 1/3 x plus 1/3. We're going to add 2 to both sides. Y equals negative 1/3 x plus 2 1/3. Or if you wanted to switch it, you don't have to. Y equals negative 1/3 x plus 7/3. Alright, so hopefully you kind of saw all those steps. If not, pause it, kind of go back and check it out again. The next page has another few examples, or try these, so give those a shot and then come on back. Okay, so here we go. We have the point 3, 2 and the line y equals 2x plus 4, and they want us to give them a line, an equation of a line that's perpendicular to this one. So our slope of our perpendicular line is the negative reciprocal of 2, so we're going to do negative 1/2. Alright, so we're going to use our point. We got our point and we got our slope. So we got y minus 2 equals negative 1/2 times x minus 3. Okay, we distribute. Y minus 2 equals negative 1/2 x plus 3/2. We add 2. We got y equals negative 1/2 x plus 2 and 3/2. That's kind of weird, so we got to make sure we change that. We got y equals negative 1/2 x plus it'd be 3 1/2, or you could put it as y equals negative 1/2 x plus 7/2. It's up to you, either way. Alright, and then the next one, I think it's the last bit for this part. We have negative 1, negative 3. I wrote that one wrong down, didn't I? Negative 1, negative 3. And the equation is x plus 2y equals 8. So they're going to make us work a little harder here too, okay? Because they didn't even put this one into slope-intercept form. So we got to get rid of the x. We got 2y equals negative x plus 8. Divide by 2. We get y equals negative 1/2 x plus 4. Okay, so our slope of our perpendicular is going to be positive 2. Okay, because that's the reciprocal of 1/2 and it's the opposite sign, so positive 2. Sorry about that extra mark there. Alright, so we're going to do y minus negative 3, which we'll just make that a little plus right now. Okay, so the negative's gone. Sorry about that. Equals 2 times x minus negative 1, which will make that a plus also. Okay, distribute y plus 3 equals 2x plus 2 minus 3 on both sides. Y equals 2x minus 1. And there you go. Alright, that was a lot of work there. Hopefully you guys are catching on. If not, don't just stop this and not figure anything out. Okay, go back, rewind it, answer some questions for yourself. Hopefully it makes more sense, and then I can answer some questions for you in the morning. Okay, so make sure when you're watching these, you watch them, you look through it, you summarize what's going on, you try to understand what's happening, and then ultimately, if you need to, ask questions. Okay, write down some questions so you can ask tomorrow. Alright, talk to you later.